Okay, thank you for being here. I know that it's hard before or after lunch, but okay, this will be a 20 minutes talk. I hope you like it. My name is Oscar Rodriguez. I'm the product marketing manager of MPS. I prepared this talk for you. That is, what are domain-specific languages and why should we care? Just like a small question, who knows what is MPS? Can you raise a hand? Okay, who knows what is domain-specific language? Good. Okay. Well, first we have the general purpose languages. These are programming language for a variety of application, and normally it takes from 1 or 2 years to learn it. Now, imagine if you can learn a programming language in 2 or 3 days. Imagine that you don't need to learn the fundamentals of programming. You don't need to learn algorithms. You don't need to know data flows or all these kind of things that developers know. So this is possible when we increase the higher level of abstraction. This means that we hide the complexity. You see what you need to see and learn what you need to learn. And we have done it before. More than 50 years ago, there were developers in machine language. And from there, we moved to assembly language. And developers, these guys from machine language, they will have a lot of resistance moving to assembly language. And then we moved to third-generation languages. And then what will be our next step? A step where you can learn a programming language in days? Well, the answer is DSLs, domain-specific languages. What are domain-specific languages? This is a definition from Martin Fowler, a computer programming language of limited expressiveness focused on a particular domain. Basically, a programming language for a specific problem or domain. Just for you to know, we're going to use JetBrains MPS. It's a language, open source language workbench for DSL development, which means it's a tool to create domain-specific languages. Okay, who's using MPS? Who's using DSL? I'm sorry. This is a very good example. This is one of our users. It's a German insurance company. These guys were making these policies, insurance policies, in Microsoft Word. And they were sending it to India, so some Indian developers, they will see this as requirements and generate C code, and then so they can insert it to the system. But of course, you can imagine that there was a lot of problems on between, because, I mean, the language is in German, and most of the Indian people, they don't speak German, plus they don't know all the insurance rules on how the insurance in Germany works. So they decided to create a DSL. So they create one very similar DSL that looks very similar to a Microsoft Word document. This is the DSL that now they're using. And the same people that they're using, that they were filling in the Microsoft Word document, now they just fill in the DSL, and this DSL generates C code. So basically, they don't need any more the Indian developers. And also, you have all the benefits from an IDE. You have code completion, version controlling, and all the fancy tricks that an IDE brings to the table. So for you to understand how MPS works, or how you create DSLs with MPS, I need to explain you a little bit about projectional editing. This is a unique technology that we use inside MPS. So normally, when the developer is writing code, they write it in text. And there's a parser that insert the text in an abstract syntax tree and then send it to a compiler. In MPS, it's different. The developer is writing directly in the abstract syntax tree. There's not a parser. So you feel that you're writing code, text, but actually you're writing inside the abstract syntax tree. So for those of you that will try MPS later, just for you to know, it's not a text editor. So it's a projectional editor. Well, this is how it looks in abstract syntax tree. For those of you, it's basically how a way to represent the code in a tree. And the advantage of using projectional editing is that you are not constraining text. You can create tables inside your code. You can create math formulas or graphs. So basically, whatever you need, whatever your domain needs, you can create it. So you're not constrained just in text. Okay, I'll prepare just some demo. First, I would like to show you one DSL. This is a voice menu system, also called IVR. A voice menu system is the system that is the recording that you hear when you call a big companies that have several options. Like, thank you for calling the name of the company, press 1 for one, press 2 for whatever. So we decided to create this DSL so it can be easy because everyone can relate to. This DSL generates 4 languages. HTML, so you can show it in web, XML, if there's a system that needs XML, Java, and asterisk. I will show you in a while. Just for you to know how it works, we decided to create a very simple DSL because the person that will use this DSL is a secretary, a receptionist, somebody that knows when somebody's in vacation, when they need to change the structure of the voice menu. So it's very easy to choose. For example, if I would like to add another option, I go here, add a new event. So even the DSL tells me the available nodes. I can use it, for example, I can just use the number 9. Let's say add the name of the option that you want to add. So you will set up the option, which means when they press 9, what is going to happen? So let's say direct call to 345. That's it. And that's how you create like a new input for the structure of the voice menu. So as I told you, this voice menu generates 4 languages. Because we're in Java days, I will generate the Java code so you can see it. And here you have to add the language that you are creating. OK. So in here, this structure generates the logic in Java. And also, we create a Java application so you can see how it looks. So even like the person can test it. I don't know if we have sound. OK, well, we don't have sound. But basically, this is a way that like the person that they create this voice menu can test it. And there's like a fancy voice there that tells you the options. Also, the 4th language that I want to show you is the asterisk. Asterisk is a service that uses this kind of, it's a system that creates voice menu. So a lot of companies, big companies, use asterisk to create this voice menu. Even JetBrains, inside JetBrains, we use asterisk. So to create this a real user case, we decided to create asterisk code or scripts so it can be a real use case. So let me show you. We have to change the language. We have Java now. I will add the asterisk one. Now, let me close Java. Now we generate the codes. I generate 2 config files. So these config files are the ones that you send to the server in asterisk, and you create the voice menu with the asterisk scripts. So this is the scripts of the asterisk, so you can create this logic of the voice menu. So how it's done now is the person that wants to change the voice menu, they have to talk to the technical support, the person that knows how to work with asterisks. Probably it's not that hard, but for somebody that is not technical, this can be really a pain in the ass. OK, so now I would like to show you how to create a language. I will create a very simple language. OK, let me just show you this. We will create a constant language, which means we will write some constants, and that will create some variables in Java. It's a very simple language but it will you can see how it works, how you can create a language with MPS. OK, from the beginning, I'll create a project. You have to name your language. I will call it constants 35. I will create a sandbox so we can make the testing. So this is your the first window that you see with MPS. You have first in the upper part, right part, you have solutions and languages. Solutions are the application that you generate. And here you have the sandbox. And L are the language constant that is the one that we're going to use to create this DSL. All these options are called language aspects. Are the things that you need that you have to do to create so you can have the language. Structure is how is the structure of the abstract syntax tree. Editor is the visualization, how does it look? Constraints and behavior is how does it work, the logic behind the abstract syntax tree, the type system of the language, and the generator is the most important one because it's where where the magic happens. It's where you change the syntax that the user is writing, the end user is writing, and change it to real code. So for this simple example, I would use just structure and editor. So as I told you, structure is the structure of the abstract syntax tree. So for this example, we need something like this. We need a node that we call it set of constants. And this node will have children from 0 to n, that every children will be a constant. So if we go back to MPS, we will first create a node that is constant. That is the children that I was talking about. It will have name, it's a string, value, string. Okay, I know it can be like a little bit complicated, but follow me and it will be simple as we go on. Now we just create the children constants, the structure of that. So now we're going to create a father. It will be another concept, set of constants. This is a root node because it's the node from which we're going to start. And we have only one property, the name of the set of constants, which is also string. And we have the children, the list of constants. And the children is the node that we just created, constants, from 0 to n. So now, with this structure, we already have this structure. So now, if I rebuild the language, just a second. Okay, ignore this. And then I rebuild the project. Now it's possible to create a set of constants. So basically, we already create the structure, the superficial place of the set of constants with the children constants. So in here, we already have the structure. But actually, it looks very ugly. So that's the job for the editor. So for the editor, we will create an editor for this concept. So the editor, as I told you, is how it's going to look, the visualization. So as we go back to the presentation, we want to look like this. The name of the constant is name. So that's exactly what we're going to do here. We're going to use a collection. The name, the constants, and in here, because the name of the concept is a property of the set of constants. So as you can see here, it's already inserted. The name is already inserted as a property of the set of constants. So if we go back to the editor, then we have to create. Okay, I know like this can be a little bit scary with a lot of options, but just follow me, please, and we'll manage. So I will have to create another collection. Okay. I just create another collection so I can put the name of the constant, of the set of constants, the concept, and then below it will be all the constants below. So we can have this visualization. So it can look like this. Set of constants, then all the constants below. Okay, so we go back and we generate this language. Now this one looks different. Now I can put full name here. And of course, this still looks ugly, so we need to change the visualization of the concept constant. Okay, so we go back here. We're going to create an editor for the children, which we want to use a collection. So how we want to look? Constant name, because we have name, plus value. So this is how we want it to be shown. Okay, so if we generate the code, it will look like this. Now it's making more sense how it's supposed to be. Okay, but still, it doesn't do anything. Now, like, we have to change the generator. We have to create the generator so we can create Java from here. So if we go to main, the generator, these are all the rules for the generator. We need the root mapping. We're just going to change this for this example. So we have to select the concept that is the root, which is set of constants. And in here, we're going to create a Java class. MPS is already built in a language that is called base language, which is a copy of Java. So we already create this public class that is basically Java. So this means that when we generate, if I rebuild the language, and I generate this solution, I will have this, what I just create, just a class. So now it's time to fill in with the information. So for example, we want to create a public static final string field with a value. This is what we want to create. The name of the class, let's put the name of the set of constants as the name of the class. So for this, to make this, we use macros. In this case, we'll use a property macro that is called. So we can add, let me just put it here. So what I just did is, for the name of the class, I will put the name of the node that I'm using, which is the name of set of constants. Which set of constants, the name is full name. It's what I put here. So now, sorry, if I rebuild the language, what is going to happen is that now the name of the class is full name, because it's the property of the set of constants. So now we want to change now the public the variables. So for this, we go back to the template, which is here. Okay. So we will use also another macro, which is called node macro, with this function that is called loop. So what I'm doing, let me just do it first. What I'm doing is that I will loop this line of code in all the nodes of list of constants, which is the children of the set of constants. So basically, depending how many constants is how many times this line of code will print. So if we also rebuild it, you will see that I have two constants. And if I generate the text, it happened 2 times. So now what I'm missing is to add the name of the constants in field and the value of the constant in value. So if we go back to the template, we will also use property macros, the same thing that we use for the class, the name of the class. So we need the field as the name of the constant and the value, property macro, as the value of the constant, because we are right now in this concept where the properties is name and value. So this is what we need to change from the line of code. So now we finish. If we rebuild the language, I have still some minutes, no? I just want to finish. Okay. Okay, if we rebuild, we see that we already have our language of constants finished. And if I would like to add more constants, say country. Okay, Mexican. So we create the variables for that. So now just back to the presentation. I think I just have 1 minute. Okay, so why bother? Why is important? So basically it's three main things: increased productivity, quality, and higher level of abstraction. The increased productivity means that there's an effort at the beginning to create the language, using the approach of language engineering. But to increase functionality, the effort is less than to start from scratch with a general purpose language. The quality is easier because it's shorter code, so it means fewer bugs. It's easy to analyze. And also, the errors are made for the end user, for the people can understand. They are not that errors for developers, like null pointer exception or errors. It will be errors that the end user will understand. High level of abstraction, this means that the communication is better because more people, even non-technical people, can really have a say in here and can really help in the development of this tool, of all the solution that they want to create. There are different industries. These are some of our users that they are working with MPS, and it can be from different industries. And I just want to finish with this quote. This is Sergey Dimitriev. He's the co-founder of JetBrains and also the father of MPS. So he said in one of his blog posts, "Sure, I can do anything on a computer, but some things take me years of effort when it should take much less time. Something is wrong here." So, dinlediğiniz için teşekkürler. Afiyet olsun. Thank you. I think there were some questions.